Thank you. Thank you. So, Namshan, today we're talking about electronic components. Electronic components. Do we know what electronic components are?
Yes,
Do you?
yes. It's your fuses, your switches, your motor,
Hmm?
your motor.
Electronic.
Well, it works with electricity. Your diodes, your capacitors.
You're on the right level. So, normally, electronic components uses low voltage. So low voltage simply means they are not using 230. We find them in things like computers, laptops, cell phones, appliances like microwaves, air fryers. They do have electronic components because they have low voltage section, or we can call it a control. What do they call it? Control panel. So are basically found there what we call a printed circuit board, a PC board. That's where we find all these kind of electronic components. So I think it's vital for us to understand what they are and what their functions are before we start learning on how to fix things like air fryers, microwaves, pop-up toasters, straighteners, digital straighteners, because all of that are comprised of all these electronic components. So that whenever there's a fault on the PC board, you know where to look or what these functions are, how to measure or test these components so that you can do your fault finding properly or better. I don't know much about it, but there's little that I've learned and that I've realized. So if we could learn all this, it might make our lives easy to do these things. Clear?
Yes.
So the first thing that I want us to learn about is the transformer. What does a transformer do? I'm not interested in an explanation to say a transformer is a device that does what. But what are the main key functions of a transformer? What does a transformer do?
To step down or step up power.
Yes, the transformer, it's either it steps up or it steps down voltage. Ne? Current and voltage. So a transformer basically has got a primary coil and a secondary coil. So a primary coil is the one that receives, and then a secondary is the one that gives. I'll just give an example. It's made up of a coil. Ne? So you find that in a transformer, on the primary side, let's say this would be the secondary, we have a wire that goes like this. So this is the primary. However, on the secondary, bear in mind, all these wires are connected. When it comes this side, there's more of this. So what do you think this kind of transformer is? Is it a step up or a step down?
Step down. Step down.
I'm referring to a transformer. What do you think this type of transformer is? Is it a step up or a step down?
To step down.
Why do you say you think it's a step down?
increase the amount of voltage that is coming to the coils. So by the time they exit, it has lower voltage.
Okay. No comment. So if it's the other way, what do you think? Between the two transformers, which one is a step down, which one is a step up?
The bottom one is not step up.
That means that
You think this is a step down, this is a step up. Why? What do you think?
Me, I'm gonna stick to my origin, the
You
origin.
say this is the step down, this is the step up.
But I'm also confused.
What do you think? Zoom. What do you think? Are you even part of the class?
I am, sir. But a step down, a step up. That's one of us.
I'm not taking the class.
But say how
Remember,
identify.
when we were talking about the motors, we said the bigger the coil, the bigger the magnetic field.
Yes.
The lesser the coil, the lesser the magnetic field. So which means
She's correct.
she is correct to say the bottom one is a step down because there's too much magnetic field on the side and there's less here. Which means this might be receiving 2.8 volts and converting it to a lower because there's less coil this side, which means there's less field. So this is a drop down. It's dropping it maybe to 9 volts. You can take it from this to that. And then on the other hand, you get it that maybe this is 230 and it converts it maybe to 3000 volts. Depending on the appliance or anything. Does that make sense?
Yes.
Which means in each and every PC board, there's a transformer. Because, and again, one thing that I forgot to highlight is that most of the components on a control panel are actually using a DC, a direct current. Most of them are using a DC. However, on a high voltage side, are actually using the AC. But others, they do have the things that convert the AC to DC because maybe they want a smooth flow of current. They don't want the fluctuations. So in a PC board, we find this, and this is a very important thing. So what do you think will happen to your device if the transformer that is on the PC board is dead? What will happen?
If
The transformer is dead on the PC board,
then there will be nothing stepping up power or
stepping it down,
or stepping it down.
which means our control panel won't be able to function because something that protects them, that transforms the voltage to the level where they are, it's no longer functional. So which means they won't be, the control panel won't be able to power on. And then in most cases, if the control panel doesn't come on, the whole device is affected. So most or almost all the components on the PC board are using low voltage, and something that drops the voltage, if it's not functional, the whole control panel won't function. Ne?
Yes.
Yeah.
It's not shooting fast.
You must understand. This must just be a general knowledge.
Yes, man, that's what I want. So
So you just write the notes that you are not gonna even look at.
The transformer up there is a the transformer is a talent since it cut power.
Oh, this one is step up. This is step down, ne? We take it from the understanding of motors where we were saying the lesser the coil, the lesser the magnetic field. If you want to increase the magnetic field in a coil, you have to increase the size of the coil. The bigger the coil, the bigger the magnetic field. So that's how they manipulate the voltage in transformers. And in most cases, transformers are used for transmissions. If they want to transport or deliver electricity in long distances, they're using transformers to step up the voltage so that it can be able to be delivered or transported in longer distances. Are we clear?
Yes.
Can I raise this?
yes.
So we must know what a transformer looks like. They differ, but the function is the same. It's either it's a step up or a step down. Inside the microwave, when we're dealing with the microwave, we're gonna see two types of transformers. There's a transformer on the high voltage, on the low voltage side, and there's a transformer on the high voltage side. And you may find that the transformer on the high voltage side uses about 5,000 volts or to 6,000 volts. And then the transformer on a low voltage, which is the control panel, takes 230 and converts it to 9 volts. 9 volts, because most of the components on the PC, it's either uses 9 volts, 5 volts. That is why even when you're measuring with the multimeter, you have to use the right unit. Don't use too much voltage for some of the components, because you might end up overheating, causing the overheat for the components, burning them. Are we clear?
Yes.
I wish we have something that we could show that when we speak about the transformer, this is what we are talking about. But when we start opening these things, the first thing that we're going to do is to identify, to say which part do we think is the transformer, which one do we think is what.
Transformer.
Yeah, yes, go. Or even these devices do have transformers. What's the other component do you think of? Electronic component. Huh? A motor. Electronic component that we find on the PC board.
Oh.
So when you open the coffee maker, did you see any motor? So what did you see on the PC board? The greenish thing.
Yeah.
Huh?
What diode?
You saw resistors. Yes. Resistors are those colorful stripes, ne? You find others it's black, brown, orange. Those colors, they have a meaning, ne? So if black is 0, it means it's 0. If brown is 1, it means it's 1. The gold stripe, it means a tolerance. Or whether of 5%, 8%, 10%, I don't know. But the color, they differ. And others have about 3 colors, others have 4, they differ. Others have 2. I don't know what differentiates them. But what's the main function of resistors? Yes. Transformers steps. This one, Yenzan, it restricts
Or it resists.
resist. That's the word that I was looking for. Resist flow of current and voltage. Next. Yes. So there are these colors on the resistor. They go like this, 0, 1, 2, I don't know, in there. Okay. Something like this. Black, brown. You can check it on internet. I'm not sure if whether I put them right. Red, orange, yellow, green, blue, violet, I don't know, maybe white, gold, I'm not sure. So if you find that your resistor maybe the first color is brown, then the second color is blue, then it has a gold color at the bottom. I don't know if they are 2 or 3. I'm not sure. It's been a while I've seen it. So it simply means what's the number for brown? 1. It's 1. So it's 1. What's the color for blue? It's 6. So those colors, they represent the resistance of your resistor, the value of the resistance of your. So when you use a multimeter, you're gonna get exactly the same value as what you get. Roughly, tolerance means between this and that. Ne?
Yes.
Because let's say our tolerance here is about 5%. So simply means whatever that we're getting here will be plus or minus 5% of the value. So if we're adding 5% of this or minus 5% of this, it will give us a rough value of what that is. And when we use the multimeter, so we're gonna try this exercise when we're dealing with the actual thing. So when we use the multimeter, it's gonna give us roughly within that range. Whatever value that we're gonna get in the multimeter will fall within that range. It tells you that whatever value that we're getting in the multimeter, you can verify by doing the calculation to say the value is correct. The value that we are getting is not over or less than what it's supposed to be. Because a value that is over beyond the tolerance won't do a proper job for what it's supposed to do. Ne?
Yes.
So I don't know the format how they put these things, but you find that in any line they've put a resistor maybe next to a transistor going into other component. But each and every component serves its own purpose, doing its job. Like we are saying, this one restricts the current flow. So it only allows a certain amount that is enough for the next component. So it resists access for the other excessive current. Any questions?
No.
Are we not moving too fast? Zumba. So a proper calculation here. Maybe I'll remember as we are busy doing that. It's supposed to be 0 point something because normally it's in kilo ohms. So we have to convert it to thousands. So if it's 16 divided by 1000, supposed to be 0.016. Then we calculate the tolerance there. Because I think resistance in most cases are measured in kilo ohms or more. What other component can we talk about? Yeah? Okay, capacity. What do you know about capacitors? Huh? They store energy.
They work like a battery to provide a boost in energy whenever there's not enough energy or current to supply.
They act more like rechargeable batteries, but they are quicker. They can charge faster. They can discharge faster. And in most devices, capacitors are what makes it more dangerous because they can store energy for a certain amount of period before they release it. So if you, depending on the size of the capacitor, when you touch it, it will shock you. So they store energy temporarily and they boost. They act as filters. They smooth your current flow. So to eliminate some fluctuation, there are components that do not allow a fluctuating current. So capacitors are there to smooth it and to boost. They boost and smooth the flow. Ne? Something does not make sense. They store, boost, filter, and smooth energy. Ne? And one other thing that you need to appreciate is that they've got symbols. Ne?
Yes.
I might not know the symbols here, but when they are presented on the sketch, they don't write capacity. They write a symbol that represents it. So even when they do a circuit diagram, they use symbols. So you need to know, you need to interpret to say, when they have written something like this, a capacitor, a symbol for capacitor is something like this. In other cases, one side is like this. Ne? So, in a circuit diagram, they will do something like this. When you see two bars parallel like this, just know that's a capacitor. So, when they explain it further, they say it has got two metal plates inside that can hold for a certain period and are not joined together. So, Bigger capacitors are what makes those devices dangerous, like a microwave. When we spoke about microwave, we said the transformer of a microwave uses between 5 to 6,000 volts. You can see 3,000 volts is what from the transformer outside. And you see how it fries the human body. It peels out the skin within seconds. So even a microwave, it ranges around those voltages. So a capacitor in a microwave, it's exposed to high voltage. So if you touch it, immediately after unplugging your microwave, you touch it.
3,000 volts in the person through your veins.
It will give you a humble pie. So you need to discharge it. In motors, bigger motors that runs elevators and other things. There are motors that uses a capacitor. Single phase motors uses a capacitor. So you can think of how much capacitor or how much is the capacity of that capacitor. So if you touch it without discharging it, you'll feel nice. What other component can we think of? We need to list all these components and try to explain them as much as possible so that we know when we start dealing with PC boards, we know what to expect. When we see a capacitor, we know what it does. And we know how to handle it, we know how to test it. All this transformer, I believe it's measured in volts, but we can use continuity to measure it. We can use resistance to measure it. We use resistance and continuity to test for capacity. What do we use on the resistor? We use ohms or continuity to test it. But in most cases, when we use continuity, we are unable to get anything from the resistor. So that is why if you don't know the resistance, or if you can't interpret the lines or the stripes of a transistor, use high value or high range of the ohms on the multimeter, so that you don't commit a mistake to use 200 ohms and you can't find anything and you decide to say, oh, this resistor is not working. So if you don't know the resistance, always start from the highest. Mega ohms go down. Does that make sense? Capacitors, what do they use? To measure. You said it the other day. What farads? Nanofarads. To measure the capacitors. We are moving, we are getting there. Electronics. It's a very interesting subject, yet a lot of us don't have expertise in it. So it becomes difficult. A lot of people who are repairing, they only repair the things that are only heating because they are not complex. It's just a flow of current and it's easy to see. But these ones are more advanced because when you start dealing with the PC board, dealing with low voltage, you don't know even how that maps moves. So it becomes very difficult. You don't know how to solve the components. You don't know how to take them out. So people avoid such kind of things, but there's always room for learning. One step at a time. Start with simple items, then you can get better and better and better. What other component can you think of?
Diodes.
Diodes. What can you tell us about diodes?
Something good at Mania, but it has something to do with direct current. Nice normally converts AC to DC or in one linear direction.
Diodes. We have standard diodes. We have Zener diodes, we have LED light diodes. I don't know why they call LED diodes. but they call them diodes anyway. Diodes, they allow current to flow in one direction. Yes. Flow in one direction. So when you measure it with a multimeter, if it gives you a reading this way, and then you swap the probes, it shouldn't give you a reading. If it gives you a reading, it means there's a problem with that. It's open because it doesn't allow current to flow in one direction. So that's standard diodes. They have the anode and the cathode. The anode is the positive side, the black side, and then there's a silver stripe on the other side. It's a negative side, and it's called a cathode. You should know that. That's a standard diode. On a Zener diode, it goes in one direction but in a reverse direction. So it's more like reddish in color. It's more like unlike the standard one, the black one. Then the LED, for sure we all know the LED diode. It's reddish in color. Maybe we'll find it somewhere. I hardly saw it in this kind of appliances. But the most important thing that we must appreciate is that it flows in one direction. And diodes can also be used to manipulate signals. So we have seen in one of the in those hair dryers where they link diodes to form something like a direction. Maybe that's how they manipulate the signal or what. And then diodes can also be used as rectifiers that converts AC to DC. Next. Converts alternating current to DC current. So which means in a low voltage, in a control panel, we'll find more of diodes because what they do is that most of the components in the DC, in the low voltage are using direct current. What other component do you think of? We are following it. We're still together. What other component can you think of?
A fuse.
A fuse? Yes. I don't want to talk about a switch. I don't want to talk about a fuse. We spoke more about them. But yes, you are right. They are part of this component.
Mention what's the resistor in
transistors. Have you ever seen what a transistor? A transistor is a component with 3 legs, unlike all these other components with 2 legs. A transistor has got 2 legs. I don't know how, but one side is called a collector, the other side is called a base, and the other side is called emitter. Okay. I don't know, between base and collector, there's no connection. I don't know, I'm just guessing, but I just know that between certain legs there's no continuity, and then there's continuity between certain legs. I don't know if the base is connected to the emitter and the collector is also connected to the emitter, but the base and collector are not connected. It's something that we're still gonna find out. Normally, I see them connected to resistors. What they do, I don't know. But what I know, they are called amplifiers. I don't know what is to amplify. So which means they have a capability of taking smaller signals and making them more louder. So Amplifiers, we find them in sound systems, basically. What do? They boost the sound. I don't know. Is that correct? DJ?
I think they help regulate and even boost the amount of electricity that goes into your subwoofers and your speakers. That's helping increase sound. I think that's what I also think.
So in a mist fan, what are they there for? There is no sound in a mist fan. Only see a mist. We only see a fan swinging. And then there's control. I don't know.
Well, you have to find out.
Yeah. So transistors are called amplifiers. Converting small signals to large sound. What other components can you think of? Spell it. So we spoke about what the transformers does, what the resistors does, what the capacitors does, what the diode does. But what makes the magic? When I press an air fryer, I choose to bake, I choose to fry, I choose to cook. What receives the information and tells the system what to do? What do you think makes that? Where is the logic coming from?
Computer box.
Yeah.
Is there not a computer box?
Computer box.
If it's a car, it's a man.
What's the function of a switch? Isn't it to open and close? Oh, these transistors can also be called electronic switches. They are also electronic switches. Thanks for mentioning the switch. So they are also called electronic switch. So in a way, sometimes they allow the current to flow, sometimes they cut it not to flow. What other component can we think of? There are many components that some of them I don't even know of. There's another component called a relay. Have you heard of this relay? In a car, there's a relay that regulates the fan. In a microwave, there's a relay that runs the fan, and there's another relay that runs the transformer. So, what is a relay? I already told you the answers.
Oh, really?
Come again?
That thing we were talking about, what it tells or it gives out the order. So what
No.
How you didn't find it?
No, I didn't. I just spoke about it. I didn't write it.
Mm-hmm.
A relay, it's an electronically controlled switch that has a coil. A relay is used to control components on the high voltage side. So when the coil is energized, so basically in a relay we find a coil and contacts. In a relay there's a coil and there's contacts. It's because we are saying it's an electronically controlled switch. When the coil is energized, the contacts meet. And when they meet, in most cases, in fact, relays are found in a low voltage side, but they control components on the high voltage side. In a car, there's a relay. That's what I say. What does it do? One of the functions, the only function that I know, it controls the fan of the car. So if the relay is damaged, your car fan won't work and you are risking overheating. Because if the fan is not running, when the car is in motion, you're not supposed to find the traffic ahead. If you find the traffic, it's gonna overheat. So a relay, it's a switch, it's an electronic switch that controls high voltage components. Are we clear?
Yes.
I'm decent.
Yes.
India. Welcome, babe.
Summers.
Electrical control switch that controls high voltage component. What else can we think of? We're talking about low voltage components that are found in a control panel, PC board basically. If you did a little bit of electronics or light current, electrical engineering, you might help us about these things. What else? What tells all these components to execute exactly what the user wants?
A button.
Yeah? Because when you press the button, you find that it's either it's linked or it's not actually linked. It's on the touchpad, and there's a belt that sends a signal into a PC board. So there's a belt. A belt is not a component, but it's part and parcel that transmit or sends message whenever someone wants to use an electronically controlled device. So when you press on the air fryer, you press a certain button to say, I want to bake for a certain period. Where is that information going to? And what gives orders to say, okay, relay, you can switch on the fan. Or relay, you can switch on the element to execute exactly what is needed for a certain period. So there must be something logical that controls, that interprets all this information and give orders to the relevant components. Yes?
Could we find a processor chip or CPU chip?
Yes. Integrated circuit. You're right. That's the thing. In most appliances, you find it. What do they call it?
CPU chip or processor chip.
They call it microprocessor.
Yes, yes, exactly that word.
So what does it do? It's more like a brain.
Yes. Or a mini computer.
Yeah. So it's more like a brain of the all thing. What does it do? It receives instructions.
It receives input, processes, and delivers output or sends out output to the rest of the.
Yeah. execute
It's a loyal servant.
yeah.
It's a loyal servant, this one.
Yeah, so it's the most thing. It has so many legs and it's almost interconnected, all the components, because you see all this have to report to it because it's more like a brain. So whenever you press a button, it receives the instruction. So which means whatever belt that we are talking about, that there's a belt that receives instruction from the touchpad. When it comes to the PC board, it must be connected to the microprocessor. There must be a link that comes to one of the legs of the microprocessor so that it can receive that information. Again, if there's a point or a pin that goes to a fan, it also must be linked to this thing. So it's the brain, it's the mastermind of everything. It's what links everything all together. We just don't know how they are linked. However, with the use of a multimeter and a proper interpretation of how a PC board is designed, maybe we could learn to do the fault finding on a PC board. What do you think controls the timer? Because most of these devices, like on a microwave, there's time. And then how much you wanna heat your food, it's time. What controls that? There's a special component, or maybe an oscillator or something, a silver round oval thing. So it's controlling the time, clocking and everything. So it's what's responsible for that. But it also takes instructions from the microprocessor. One other thing that I want to talk about that I saw, I think this is the last one. There are many that I don't know. It's called an inductor. So an inductor and a capacitor, they are similar. But this one, it comes in a, I saw it on a hair dryer. This one, inductor, we find it stores energy and it boosts, it filters, it smoothes, but in a magnetic field form. This one stores energy in an electrical form. This one stores energy in a magnetic field, which means we find this on the coils. We could just assume it's a capacitor, but it's actually an inductor. It stores and boosts. We find it connected to the coil of the motors. Does that make sense?
Yes.
Do we appreciate and understand all these components? So if we can know what they do, then how do we do fault finding on a PC board? That's another thing. PC board uses very tiny or small components. They are very small. Others are even small. And they have measurement, they have units on them. Sometimes it's not even easy to see the unit. They're using that glass thing. What do they call it?
Microscope.
To just to zoom in and magnify and see what the units are. So for you to do a fault finding on a PC board, let's say your air fryer does not come on it on. What's the first thing you're gonna do? You check your power supply. So they have all these advanced appliances. You find that there's a power supply, there's a fuse on the power supply. You check the fuse is right. Every component of the power supply is fine. You check, you trace, you can see that, oh, the current is actually flowing and it goes to the control panel, but from the control panel, there's no power at all. So which means the power can flow in. There's nothing on the power supply. But on the control panel, that's where you need to focus on. What's the first thing that you want to do? When you do fault finding? Any ideas? Visual inspection. Visual inspection. Because if a resistor has bent, they explode. This one's when there's most of them actually explode. For an example, a capacitor, it has two legs like this. You find that maybe it's black or it's blue. When it explodes, you find that the top part here, it expands. You see, if you see a capacitor expanding here on top, it's supposed to be flat. If it expands, it means it has blown. So that's the component that you need to replace. Because we are saying capacitors are acting as filters, and they are smoothing the energy, electric current. So if it's like this, which means the flow is affected, it won't work if the capacitor is damaged. So you'll see it expanded or it will blow. Sometimes when you open it, you find that the whole PC board or a portion of the PC board, it's black because one component exploded and affected others. So you do visual inspection, and then the next thing after doing the visual inspection, you can clean it. What do you clean? You can use alcohol, spirit, or anything, but don't apply too much of it. Use a smaller brush and wipe it, or use a damp cloth. Don't avoid using water because water takes time to dry off. Use something that can quickly dry off. But too much of it will burn the board. So don't apply too much of it. So even when you use alcohol on the brush, you have to shake it before you brush it. So that immediately when you remove it, it dries. And then there are things like cockroaches. They I don't know why, they enjoy settling or camping on the PC board. And they create dirt there. That dirt at the end of the day prevents a flow of current. Remember we said it's a low voltage thing. So it gets easily affected by the clouds and everything that those things live there. So that is why applying alcohol or cleaning that area will help you. That's if when you do a visual inspection, you can't see any blown fuse, any blown resistor, any blown capacitor, any blown diode. If you can't see all that, clean it and see. After cleaning, check if it cannot work. If it doesn't work, which means you need to test components one by one. I would say start from where the current flows in, but it's very complex. There are so many streets there. Go to Durban and you are new, you don't know where the taxi rank is. You know where do they call that place where they sell all these kind of things? At the market. You will get lost. It's next to the station, train station. Is it? It's not safe there. I hope it's very safe. I went there twice, but since when I was in the dark, I thought it was safe.
But you could do so much, you let
It's like Park Station.
Park Station is much better. You see Durban, like you don't even want someone to call you while you're walking there because they take the phone always. When they see you, you're not from here.
Touring the first year to hey.
I know at the beach they stay.
Yes, even at the yabo whenever.
Yabo ema-rice mineral. Bangena phakathi ema-rice bezofuna ama-pieces.
It does the same thing as it stores magnetic field.
Oh, okay.
Unlike the capacitor that stores electric energy. So it's a filter, it smooths magnetic field in motors, in coils. Ne?
Yes.
So we were still on the part of how do you do fault finding on a PC? You know, PC, but it's there are so many lines there that a lot of us don't understand. But it's easy to detect a blown component. So other components are easy to detect. But something like a relay is a black box there on the PC board. It's not easy to see if it is blown. If whether it blows. I don't think it blows. It's either a coil, one of the windings of the coil gets broken, you don't know about it, or the contacts do not meet anymore, do not make contacts anymore. So, but how do you do it? Other people use a 9-volt battery or 12-volt battery to put on the terminals. It has about 4 or 5 legs. So they put on 2 legs. So it makes a click. When it makes a click, they know that when the coil is energized, it makes a contact, which means my relay is working. But in an appliance like microwave, you find that sometimes this kind of fault happens. You find that when you switch on your microwave, it runs, but there's no heat. And the problem is not either on the capacitor, diode, magnetron, or transformer, but the transformer did not switch on. The transformer did not switch on because it's faulty. It's because the relay that has to switch the transformer on does not switch on, does not make a contact. And if it doesn't make a contact, it means your fault is not on the transformer, it's actually on the PC but on a relay. So you need to test the relay. So if you find that your magnetron does not generate heat, a heat that you can use your hand and feel that it's warming up. So after running it for 2 to 5 minutes, your transformer has to heat up, because what it does is stepping up voltage. It has to heat up. So, but after running for 5 minutes and you put your hand, you feel that it's cold like ice. What does that tell you? It tells you your transformer is either not working or it's not switching on. The relay that is switching the transformer on is not actually doing that. It's not sending the signal. So it takes a good technician, or not a smart one, a good technician to be able to think, okay, I don't have to replace the transformer, because you can replace the transformer and still the same problem exists. So then you need to know, what controls the transformer, what switches on the transformer. Then you have to change the relay. Now you need the skill to use a soldering iron. You burn it out, you take it out. You test it with the 9-volt battery. If there's no click, if you are able to open it, you can open it and check the coil, check the contacts, and close it there. But if you can't, go to the spare shop, buy another one, and put it in. Then your microwave will heat up. Are we clear?
Yes.
So what confuses us is the things like resistors, capacitors, diodes. There are a lot of them on the PC board. Whether it's a mist fan, whether it's an air fryer, you find that there are about 3 or 4 resistors. What do they do? Which current are they regulating? Those are the things that you need to be able. That is why the best way is to do a visual inspection and check each and every component if there is no damage. So, but if you fail to see the damage, check the connection. Things that bring in the signal, are they bringing the current in? Are they bringing in the communication that's supposed to be executed? So there you need to check all the belts or all the wires that bring in current into the PC board. Are all your components connected properly to the IC, microprocessor? Microprocessor, remember, here I'm talking about appliances that have the microprocessor. Are they all connected? So we need to hear them. We need to understand that. So there are things like digital straighteners. We spoke about it the other day to say there's a sensor. We didn't talk about the sensor. A sensor is also part of the component. So a sensor, if your straightener is overheating, it means your sensor is detecting that there's too much uncontrollable heat. Then it will start flickering to show that it's overheating. So you need to replace the sensor, or you need to do something about the sensor. I don't know how to repair the sensor, but those are the things that you need to look into. Clear? So when we come back, we're gonna discuss. Actually, we're not going to discuss. We have discussed enough. Straighteners. We are going to repair straighteners. So hopefully we do have digital straighteners where we're going to be able to see all these components and be able to test them. Hopefully they are faulty. Maybe we can be able to repair them. But we know the function of a straightener. Do you know a straightener? You don't know a straightener? You are not romantic. I thought you were God.
Loko qonzile guys.
I You've never seen it. So it's more like an iron. It uses heat. So they differ. An analog one is just one temperature. You switch it on, then it's one temperature. But there are more advanced ones which are digital. You can choose the kind of temperature you want. Brazilian. But as an entrepreneur, you should see opportunities everywhere. If you find an opportunity in that, you need to understand. And you have to know the product better than the user, so that you can explain it better. They know how it works. What I hate about straighteners, the reason why I don't fix them, what I hate about them, is that they're making them, because it's something like this, they're making it very easy to open. They hide their screws, and it's very complicated. But the most common problem with straighteners is the cable. So the cable is designed that it can swing. So sometimes it loses the contact here. You see, we have seen the base of a kettle, how it is. The round one might be the neutral, the middle one might be the live, sometimes might be the earth. So they differ from kettle to kettle. Same thing happens with the straightener. You find that the middle one is a live, the surrounding one is a neutral, something like that. So you need to make sure that there's enough contact. You adjust whatever place that needs to be adjusted. So whenever you do fault finding, make sure that from the cord there's current that flows in. Does it go to the PC board? From the PC board, check all the resistors, check all the capacitors, check all the inductors on the straightener to check. Because I think there are about 2 or 3 faults, if not 2, that are always visible. It's either there's no power at all, and when you swing that cord, it shows that it catches power but it's loose, so you know the problem is here. But sometimes you find that there's no power at all. If there's no power at all, it means there's chance that the current is flowing in, But something on the straight, on the PC board has blown. And with the straightener, what I hate as well is that the components are very small. The resistors are very small. The inductors are very small. So it's not actually, is if the burning didn't show that the area is black to show that something has blown, it becomes difficult to do one by one component test. But in most cases, check your capacitors. It's what kills the whole thing. The other one is when it's flickering. So the buttons, they all, whatever on the screen, they are flickering. Just know that, check your sense, it's overheating. It's because of overheating. Ne? I don't know, any questions? Questions, I just said. No questions. Will you be able to catch up with everything that we've done? We have people who can open an iron in 10 minutes and put it back.
Come on, shall you record that? I'm going to show Zoom.
This one done.
So, but this exercise, we agreed that we're gonna do it more often so that people will get used to opening, identifying key components and closing. Even if they are not faulty, they have to get used to that. But for those that are faulty, they have to do fault finding.
I'm making a friend there. 15 minutes on the friend.
So straighteners, hopefully, I saw 2 there. Hopefully we have more, because I requested for at least 5. So if there are 5, at least we might do 2, 2, 1, 1.
Yes.
So that when we are in pairs, it's not like when there's 5 of us or 6 of us. When there's 5 of us, others don't even pay attention. And at the end of the day, they repeat the very same mistake that we want them not to do. Suggestions? No. What time is it? Yeah? Oh, wait. On Fridays, one normal 2. Okay, no. Let's go for lunch so that we will have enough time. Thanks. Thank you so much.
Thank you.